Okay, and for problem number 4, I would use theorem 717 because it's the same, circle with a secant and tangent from the same point. But the point here is D instead of P. But otherwise, it transfers just the same. So you see here from P to E is the tangent one, so this is going to be from D to A. So the length of DA, if I square that length, that has to equal whatever DC times DB is. So if you look over here, the length from P to B is this whole segment here times the length of P to A. So instead I'm using from D to B and from D to C. So dA squared has to equal dB times dC in this case. And how that transfers is from D to A is 6, so 6 squared has to equal the length from D to B is going to be x plus 5 more, so I'll just put x plus 5 there, times the length from D to C, which is x. And then you can solve that algebraically in whatever, or graphically. Personally, I like to use factoring if I can, so I'd subtract 36 from both sides. And I would solve this just using factoring. So I'm looking for numbers that when I multiply them together I get a product of negative 36, but those same numbers when I add them together the sum would equal positive 5. And so then I usually just list out everything that would give me a product of negative 36. Like 3 times 12 is 36, but there's no way I could add those together to get 5. So then I'd try maybe 4 times 9. That would equal 36. And I could get a sum of 5 as long as one of those was negative, because negative 4 plus 9 is equal to 5. Negative 4 times 9 is equal to negative 36, which means I'm going to use my factors of x minus 4 and x plus 9. And now when I multiply it out, I would get x squared plus 5x minus 36. And then of course you set each of those factors equal to 0 and you solve. So there's 2 answers technically, and they are 4 and negative 9, but since negative 9 can't really be a length, I would say x equals 4.